Hello everyone, this is Professor Vishal Gupta at the USC Marshall School of Business. This video is for BUAD 425, Data Analysis for Decision Making. In the video, I'm going to review some of the basic skills we learned in Excel for Lab 1, KPIs and Dashboarding at Applichem. Let's get started. I've already downloaded these text files from Blackboard to my computer, so the first thing I'm going to do is import them into Excel. So I'll start up Excel and create a new workbook. We went over in class that there are many ways to do this. I'm going to do this by using the Get External Data function from Excel. For safety, I'm going to follow the lab instructions and rename the first sheet Production Data and upload the second set of tables onto a second sheet, which I will call Cost Data. Rather than watching me upload all of these data files, I'm going to pause the video now and upload them. You should do the same. Alright, you'll notice that I've loaded all of the data into Excel now. I've actually added some formatting too to make it somewhat easier to read. For example, there were many digits in these numbers, production, raw materials. To change the number of digits shown, I highlighted them, went to the home part of the ribbon, and used the arrows to show more or less digits. Similarly, I boldfaced some of the headers and used gray coloring here to make them clear that they're headers and not data. I've also put all three of the other tables on this second tab, Cost Data. Here are the information about the plant cost data, the exchange rates, and the number of workers. There are notes about the units that each of these things are measured in that will become more useful as the case goes on. Looking back at the case now, we see that the first thing we have to do is to compute several of these KPIs, like the average output by plant per month in millions of pounds, the average raw material cost by plant per month, etc. As discussed in class, this is somewhat difficult because there's a different number of days in each month. Consequently, what I'm going to focus on instead is computing each of these numbers by day, and later on in the lab we'll use a pivot table to aggregate them by month. So to get started, I'm going to create a new sheet, which I'll call Data Cleaned, and copy over my existing data from production.data into this sheet. I'm only doing this so in case I make a mistake, I don't ruin the original data that I had. Now I look back at the case and I'll see that the first KPI that it asks for is the average production by month, but I'm going to interpret that as the average production by day. I'll see that on this sheet I already have this number. It says that there's 0.046 million pounds of releases produced in Mexico in January. So I don't need to do anything else. The next thing I need to compute though is the average raw materials cost by month. Here we'll see in column D that I have raw materials, but if I note from the original production data, this is a number measured in millions of pounds of releases. In fact, I'm going to augment this column header to make that especially clear. So to compute the raw materials cost that I pay each day, I'm first going to need to know how much I pay for each pound of releases. So fortunately, I have that information in the cost data here. So I'm going to need to perform a Vlookup to get the information by plant for the raw materials cost into this page for Data Cleaned. For those of you still having trouble with Vlookup, the easiest way to do this is to first look at the table that you're interested in this case this one, and ask yourself, how are the rows labeled? In this case, the rows are labeled by the plants, Gary, Frankfurt, Mexico, and Sunshine. The next thing you should ask is in which column is the data that I want? Well, in this case, the column that we want is raw materials cost, so it's in the first, second column of the table. So the formula I'll write for the VLOOKUP is equals VLOOKUP. Then I'll remember what were the rows labeled by. They were labeled by the plant, so I'll supply the plant information, comma. Then I'll supply the table that I want Excel to use to look it up in, being sure to include the column for the plant information. And then I'll tell Excel to look in the second column, because that's where raw materials are located. And I'm going to add a false, as we discussed in class, because I want an exact match. I'll go back and I'll add my dollar signs to make sure that I lock in this table in an appropriate place. And then I'll extend this all the way down to the end of the sheet by double clicking. Whenever you do a VLOOKUP, it makes sense to go back and check one of the values. You should definitely check something further down the sheet. So I'm going to scroll to somewhere in Frankfurt and check that for Frankfurt, I'm seeing that the raw materials cost is 40.644. And if I check on my cost data, for Frankfurt, the raw material cost should be 40.64. So I know I've done it correctly. Now this is the raw materials cost per 100 pounds in local currency. What I actually want is the total raw materials cost, because I didn't use 100 pounds on January 1st, I used 0.046 million. So to compute the raw materials cost in local currency, I can take this amount, which is what I would pay for 100 pounds, times 10,000, which will tell me how much I would pay for 1,000,000 pounds, times the millions of pounds of raw materials that I used that day. And again, I can extend this all the way down. If you're still having trouble with VLOOKUPs at this point, I suggest that you take a break from the case for a moment and think about computing instead the operating cost per 100 pounds, local currency, and the labor costs per laborer, again in local currency. These are both VLOOKUPs that are very similar to the raw materials cost per 100 pounds local that we computed here. I'll pause the video for a moment while you try to compute these two columns. Alright, hopefully you were able to do the VLOOKUPs to find the operating cost per 100 pounds in local currency and the labor costs per laborer in local currency. Let's get back to the case. The KPI we're interested in is the raw material cost paid each day, and right now we've computed this in local currency, but the case asks us to compute it in US dollars. To convert this to US dollars, we're going to need to look up the FX rate. Fortunately, we have this FX rate in this table here, and we're going to need to do a VLOOKUP to move this FX rate into the data clean sheet. What we'll see is that this will be a slightly more difficult VLOOKUP than the raw materials cost lookup that we did earlier. Let's get started the same way though. Looking at this table for the FX rate, how are the rows named? The row labels here are the month name, given as a word. If I look back at my sheet, I don't have the month name given as a word. What I have is the date. So in order to do a VLOOKUP, I'm going to have to insert a column. As we did in class, I'm going to call this column month number, and I'm going to use Excel's built-in function month, and I'll pass to month the date. Month takes a date and returns the corresponding month number for that date. So if I extend downwards, I'll see that when I'm in January, month number returns a 1, while I'm in July, month number returns a 7. There are a number of other date functions in Excel that you should learn and memorize. Alright, now let's look back at our FX table. We have the month number, but remember this table is indexed. It has row labels of the month name. The easiest way to fix this is to insert a column. So I'm going to insert a column here, shift the cells right, and add the month number for each of these months. It's important that the month number is the first column of this table. Now when I look at the table, the rows are labeled by the month number, which I do have on this sheet so I can do my VLOOKUP. The second question I should ask when I do my VLOOKUP is which column am I interested in? This is where things get a little bit more tricky, because the column that I want will depend on the plant. So for example, when I'm looking at Mexico, I'm going to want to look in the 1, 2, 3, 4, 5th column. But when I'm looking at Frankfurt, I'm going to want to look in the 1, 2, 3, 4th column. To get around this, as we did in class, I'm going to insert one more column here, which I'm going to call the plant column. What I'd like to write is a formula here in these cells that will tell me which column of the FX table I should look at when I do my VLOOKUP. So for example, the formula should return a 5 when I'm looking at Mexico, and it should return a 4 when I'm looking at Frankfurt. So as I did in class, I'll do this by making a small auxiliary table, which I'll put here. And I'll write Gary's 3, Frankfurt's 4, Mexico's 5, and Sunshine is 6. And why? Again, because Gary is the 3rd column of this table, Frankfurt is the 4th column of this table, Mexico is the 5th, and Sunshine is the 6th. Remember, I wanted to fill a formula here that would return which column of the FX table to look in, and now I can do that with a VLOOKUP. I'll write equals VLOOKUP, look up the plant, because that's how the rows are labeled in my table. In this table, and return to me the 2nd column, which is the plant column. I'll go back and add my $signs. And extend all the way down. And we'll notice this formula does exactly as I asked. When I'm looking at Mexico, it returns a 5. When I'm looking at Frankfurt, it returns a 4. Now I'm finally in a position to compute my FX rate. I'm going to type looking one last time at the FX table, I'll remind myself the rows are labeled by the month number, and the column I want depends on the plant, but is given here. So I'll type equals VLOOKUP, look up the month number, because that's how the rows are labeled in this table, and look at this column. I'll go back in and add my $signs and extend all the way down. It's a good idea when writing VLOOKUPs to check your work, so I'll scroll down to somewhere in Frankfurt or somewhere not in Mexico, and I'll see that the FX rate for Frankfurt in October is 1.3581, and when I check my table, the FX rate for Frankfurt is 1.3581. Now, the case asked for the raw materials cost in US dollars. So I can combine all of the work I've done so far to take the raw materials cost in local currency, multiply it by the FX rate, and get the raw materials cost in US dollars. Which I can see are now much more comparable across the different plants. Let's take a moment to recap what we've done so far. We're looking to compute several KPIs, and for each KPI we thought about which information we needed on the sheets. Sometimes that information was here on this sheet already, for example like the production amount, and in other times we needed to pull it via VLOOKUP from some other sheet, like the raw materials cost. We did a series of VLOOKUPs, and for things like the raw materials costs, the operating costs, and the labor costs, these VLOOKUPs were very simple because the column we wanted was always fixed. For other VLOOKUPs, like the one for the FX rate, they were slightly more difficult because we didn't have the row name or that the column number would change when we wanted to look up each number. so we had to compute some auxiliary values. But overall, all these auxiliary values were put together to compute this, the raw materials cost in US dollars. You now have all the skills to compute the remaining KPIs that are asked for in the case in question 1 per day. So I'm going to ask you to go ahead and compute each of those KPIs on a daily basis, not for the month. Remember, after the break, we'll see how to use pivot tables to aggregate these values. You may need to do some more Vlookups and some manipulations to compute these numbers. As some hints, the operating cost per 100 pounds in local currency and the labor costs per laborer that you computed here in columns H and I will probably be helpful. You'll also need to do a lookup to find the number of workers each day. That lookup is going to be very much like the lookup that you did here in column L for the FX rate. Finally, yield, if you've forgotten, is just the total production amount per day divided by the total amount of raw materials per day. I'm going to pause the video now and allow you to compute and complete the rest of this worksheet, computing KPIs again per day. All right. Hopefully you were able to compute the rest of the KPIs on a daily basis for Applichem. The case asks for these KPIs over a month, either summed or averaged, and remember this is somewhat difficult to do because there's a different number of days in each month. So what we're going to do is use pivot tables to do the aggregation for us. This is slightly different on Mac and on Windows, but it's very, very similar. On Mac, I'm going to go to Data, Pivot Table, and on Windows, you would go to Insert Pivot Table. And this should bring up the Pivot Table Wizard. The Pivot Table Wizard first asks me where is my data located, and it guessed that it's here, which happens to be correct, and asks me where would I like to place my pivot table, which is on a new worksheet, which I'm going to say OK. If you're on Mac, you should see something like this appear. On Windows, the layout is slightly different. It looks like this. But importantly, what I'm going to work with is the builder, which has row labels, column labels, and values. The basic idea of pivot tables is it takes your data and breaks them up into separate pieces in buckets, and then computes a summary of all the data in that bucket. As we discussed in class, the basic idea of pivot tables is to bucket your data into different groups and then compute a summary for all the data in each group. So in this case, let's start by thinking about the production amount, and I'll take production from here and drag it into this section called values. And you'll see that the pivot table is now filled with the sum of production. This was the total production in millions of pounds over all the plants. I want to see this though broken down by plant, so what I'll take is I'll take the plant here from field name and I'll drag it into column labels. Now you can see that the table has split up all of the data by plant and computed the sum of production separately for each plant and a grand total across all the plants. In fact, I want to see this split down even further by month, so I'll take month number and I'll put it in the row labels. And now you can see that I have each individual month and each individual plant, and this is the sum of production in that plant in that month. So for example, in Gary, in July, 1.182 million pounds of releases were produced. What if we didn't want to see a sum of production? We can go here to where we have in values, sum of production, click next to it, and in Windows you'll have to click value settings, and we can choose a different function to see. For example, the average. There's lots of other things you can do with pivot tables, and I suggest you play around. For example, I could take these plants from the column labels and put them in the row labels, and now I'll see a slightly different version of the same information. For January, here are the 4 plants. For February, here are the 4 plants, etc. I could switch them around to put months across the top if I wanted to look at the table in this direction. Or I could look at 2 values simultaneously. So for example, in addition to looking production, maybe I would like to take sales here from the field name and also put it into values. And you'll see that now I can see production and sales simultaneously for each plant. This is beginning to now look like actual business analytics where I can start comparing these values to look for patterns and interesting information about the plants. I suggest you do this and play around to see what you can learn. Personally, I don't like to look at two sets of numbers simultaneously. I find it difficult. So I'm going to remove sales, and I'm going to concentrate on production, and I'll move back to looking at sum of production. And I'd like to look at what does a chart look like for this information. So generally what I'll do is I'll copy this information out of the pivot table. I'll place it on a new sheet. I'll remember that these row labels were the month number, and maybe I'll rename them. And now I can do things like create a chart. This differs again slightly on Mac and Windows. On Macs, I'm going to go to Insert, Chart, and on Windows, I believe it's located here in the ribbon. And I'm going to look at a line chart, line, not stack line, with markers. And I can now see chart for each month what was produced in each plant. Looking at the information visually is often helpful. This is a good time though to remember what we learned in dashboarding about labeling things appropriately and making them easy to understand quickly. So you can look at a variety of chart layouts here in Excel that might be more helpful. I'm going to add a title. And be sure to add an axis as well. You're now in a position to actually form pivot tables and summary monthly KPIs for all of the KPIs in question 1, and to start analyzing them for interesting features in the data. You might also want to compute alternate KPIs that aren't listed in question 1 as described in questions 2 and 3. Remember, overall, your goal is not to compute these numbers, it's to interpret them to look for actionable business recommendations. So I suggest you work through this, compute some more KPIs, and start to think about them. When you're done, you should usually end up with a solution that looks like the one on Blackboard, which allows us to look at the individual KPIs asked for in the case, some other KPIs, and a sample dashboard. You should then think about what recommendations you would make to Joe Spadaro, and we'll speak in class. If you have any questions, feel free to swing by office hours or drop me an email. Good luck with the rest of the case, and fight on.